So 8-bit microprocessor signal description. The 40 pin IC, okay. So overall 40 pins are there. This is not a pin diagram. I'm telling clearly, this is not a pin diagram. 40 pins are there. The pin diagram is what? Every pin has some number is there. The order follow. Okay, you are not like that. Okay, the 40 pins are there. The main is what? Signal diagram, signal description. So the 40 pin signal, no, the some pins are input, some are the what? Output. You can see here almost all the pins are input like that. Okay, except this one only, but almost everything input or not. No. Pin direction important actually. Can you see the arrow mark now? The processor input now. Okay, here some is a mostly your output now. Output or maybe some bidirection also. Okay, the direction of the pin important. Okay, here both are no, the arrow mark is the ultimate here. There is signal description. Some pins are acting as the input direction of the processor. Some pins acting as the output direction of the processor. Some of the pins are what? Bidirectional also. Okay, pin direction is very, very important here. So out of the 40 pins, you divide into some groups also. You can see here supply voltage and oscillator. Oscillator what? 6.144 MHz. Crystal oscillator. Okay, 2 pins are gone only. Supply voltage ground what? 2 pins are gone only. Okay, the serial is a separate the family serial. So most of the device understand serial communication. Process understand the parallel communication. So conversion of serial to parallel or parallel to serial. You said no, SIPO, PISO. Okay, see, SID, serial input data line. The data is coming serial now. Okay, microprocessor convert what? Serial to what? Parallel. So parallel to serial out only. Parallel to what? Serial out. Microprocessor transfer data to parallel to what? Serial out. Microprocessor receive the data from serial to parallel. So internally some circuit is there actually here. Internal circuit is there. Okay. So serial into what? Parallel out. What is that? Parallel out what? Serial in. Parallel, yeah, parallel in. Parallel in what? Serial what? Out. Parallel in and serial out. So SID and what? SOD. There's some device is there, no? Some kind of device. Okay, the device can able to get the data on device. The basically, no, we can simply call nowadays no, U short, UAR, RT, U short like that. Next, I just now told now how many hardware interrupt support 805 microprocessor? 5. 5 hardware now, nothing but 5 pins compressor. So you can see, we'll discuss interrupt more clearly next. So they are called external initiated signals only. So whenever if you receive interrupt now, microprocessor gives acknowledgement also. Acknowledgement is given on now. Acknowledgement. Okay. And one more signal is missing here. Is a hold also, hold signal only. So now the device rising interrupt to INTR. Microprocessor acknowledgement, no? Acknowledgement. Microprocessor response given. Acknowledgement nothing but no, the microprocessor telling about interrupt receiving like that. Acknowledgement. INTA. Acknowledgement low pulse only, low pin. So hold is a high priority interrupt. Hold also interrupt only, high priority. The interrupt generated by the DMA, direct memory access only. Whenever hold interrupt occur, microprocessor gives response given, acknowledgement only. There is also acknowledgement only. Response given, the hold acknowledgement only. Hold corresponding hold acknowledgement, INTR corresponding INT acknowledgement only. Okay, the 2 interrupts only. Every interrupt have corresponding acknowledgement line is there only. Okay. Ready. So ready is there. Is all input only. Ready. What the purpose of ready? Device slow communication, processor faster communication on that. Whenever device is ready, inform to the processor, I am the ready like that. So that like a indication like that. Indication. Okay. Whenever ready signal occur, processor understand. Okay, device is now ready. Now processor do the next step on go. Just a trigger like that on information. The interrupt like that. Ready also. But the synchronization point of view. Synchronization between the device and the processor. Reset in bar. So every the hardware board have a reset button. No? Reset. Whenever reset button you press no, connected here only. Whenever reset button you press nothing but they also interrupt only. They also interrupt. The reset is a high priority. Whenever reset interrupt occur, microprocessor no, the everything entire content go to the 00. All the resets no, you go to starting of the programming. No. You start the beginning of the your system on starting. Your program counter hold the starting of the program address or no. Understand? No? So starting moment can go now, reset bar. Clock out. The meaning of clock out. So microprocessor surrounding so many peripheral ICs are there, peripheral supporting ICs are there only. Example of the UART, I2C, timer, keyboard controller. So many supporting ICs are there on microprocessor surrounding only. But somebody need a clock also. Those are all digital circuits only. So microprocessor generate the clock to output also. Microprocessor onboard clock is there. What clock? 3.01 mega. This clock generate the output also. But somebody need no provide clock also. The clock out. Anybody clock required surrounding is providing now. Reset out is also output on reset out. Surrounding so many chips are there. Microprocessor reset the anybody. Because the microprocessor is a master of the computer, no? Master, okay? Anybody to reset now. Surrounding slaves are there, surrounding, no? DMA or timer, anybody no? Reset now. Reset out is there, anybody. Because the master now. Microprocessor. Master the reset the memory controller, anything, anybody no? Common. So next one. Next one you can see the all are okay. Already study also. 16 address lines are there. And what? 8 what? Data lines only. 16 plus height. How many pins are required? Total how many required? 24 pins required on that. So, but here you can observe. So address lines are divided into two parts only. Lower address line A0 to A7. Higher address line tell me A8 to A15. Understood everyone now? So lower address lines combined with the data lines only, multiplexing only. So the here 8 lines are the physical 8 lines only. This 8 lines you can use the lower address line as well as a data bus. Multiplexing one. So because the multiplexing are only how many wires are there? 8. So 8 plus 8, how many are there? 16. Okay. Otherwise, how many pins you want to tell me? 24. So the meaning of multiplexer bus, the two different functionality combined together. Address bus separate one, data bus what? Separate, but combined together only. Okay, yeah, address and data. No, see AD. Address and what? Data. Address and what? Data. So one pin is a AD0, one line. Nothing but it can work. Is acting address also, acting as also data. Multiplexing. So why you can go on multiplexing concept? What advantage? Reduce the number of pins. Because the multiplexing your pin size 40 pin only. Multiplexing is not there. How many pins required? How many required? Tell me. 48 pin. How many required? The pin size increasing. Obviously, size of the IC also increasing now. Obviously. So multiplex reducing now. So the one concept. So multiplexing advantage is the advantage is definitely reduce the pin number. Okay. What advantage? Reduce number of pins. Reduce IC number of pins or no. The advantage. But drawback also there only. Disadvantage also there only. So because same line address will be the data is there. The disadvantage, it takes some time to separate now. Address separate, data separate, we need to separate no. But we need to separate the address and data bus. The microprocessor spend some extra clock cycle. To spend extra clock cycle to separate the both only. Cycle. Extra time period. Clock cycle to separate what? To separate, yeah, data and address bus. Separate. To spend extra clock cycle. One clock cycle is, I told now, 0.33 microsecond. What clock cycle time period? 0.33 microsecond. No? Frequency 3.01 mega. Time period is 0.33 microsecond. So one extra clock cycle is how much time spending? 0.33 microsecond. So because of the other drawback, it can spend 0.33 microsecond time to separate the address and what? Data. It takes some time now. That is disadvantage on it. How to separate this one thing? We can do the separate control line is there. Special control line is there. The special ALE is called a special control line. ALE. Special control line. With the help of the ALE, we can separate the address line and data line on it. ALE separate it now. The name also clearly ALE. Address latch enable. What is ALE full name? ALE full name, no? Address latch enable. So with help of ALE, you can separate the address. The three are called what? Hello. The three are called what? I mean, control lines. The control bus na? The control bus na? The three are control bus. Correct or no? The address bus, data bus, maximum multiplexing. Address line, data lines, control lines. So you can see IO by M bar. The pin indicate the two functionality only. So the pin high nothing but IO operation. The pin low nothing but memory operation. IO by na IO by. The pin perform IO operation and also what, tell me, memory operation. The pin high is a IO, pin low is what? Memory. That's why M is a complement. Understand now? For example, 0. The meaning of 0, which operation? Memory operation. Which operation? Memory operation. And the read bar 0, which operation? Read operation. So write is a disable only. Write is what? Disable. Overall, which operation? Overall, which operation? Memory read.
Memory read.
Memory read operation. Understood? So microprocessor, I told yesterday, microprocessor mainly perform how many operation? 4. 4 operation. Okay. The control line generating now. Control line. No? I don't know control line. No? First to the address line. Second, what I mean, data line we are reading or writing. But third step is that generate the control line. Generate the control line. So 0, 0, 1 is a memory read operation. 0, 1, 0.
Memory
0, 1,
write
0.
operation.
You indicate what? Memory
Write operation.
Memory write operation. Because you are write operation. What about 1? IO 1. IO. 1 indicate what? Tell me. IO.
Input IO.
IO tell me. IO read or writer?
Read.
Read.
Read no? Read is enable. Write is what? Disable.
Yes.
Because low signals na. Look signal. This one tell me. IO. IO tell me. Right. So this pin is a no confusion. This pin high nothing but IO. This pin low nothing but memory. Is a low nothing but read. High is what? Read disable. The meaning of bar is what? The low signal only enable. The signal is active whenever the low only. Okay. Okay. 2 more status lines are there. Status lines are there. Okay. What status lines you can see? S1, S0. 2 status lines now. Actually, the 2 status lines now connect the 2 LEDs actually. 2 LEDs you can connecting actually. You can connect the 2 LEDs now. The LEDs are telling about the status of the processor. Status now. Process status telling now. The 2 LEDs are there connecting now. So you can see the 2 LEDs nothing but the 4 combination now. Both LEDs are off. Okay. 4 combination are not now. Okay. Whenever both LEDs are off only, off. Okay, no, the S0, 0, S1, 0, both LEDs are off or not. So this indicate the microprocessor status only. So both LEDs are off nothing but microprocessor right now currently not running only. Microprocessor is enter the halt status only. Halt. Stuck up. Microprocessor halt. It's a very dangerous situation. Okay. Microprocessor cannot do anything actually. When the microprocessor go to halt nothing but microprocessor cannot understand the instruction or programmer mistake. Okay. You go to the generally the halt mode on now. Okay. So the no LED blink nothing but microprocessor hang up. There are people indication like that. Okay. 0, 1 indication is a microprocessor just now perform the write operation. Just now perform which operation? Right. 0, 1. Okay. First LED is a no, the S1 is a 0. S0 is what? Tell me on. S0 on is a write operation. Okay. S1 on, S0 0. Which operation? Read. Microprocessor just now perform which operation? Tell me. Read. Both LEDs are on only. Both LEDs are on. Indicate microprocessor perform which operation? Fetch. The meaning of fetch. Microprocessor load the instruction from the memory. Load the instruction from the what? Memory. Okay? Because memory contains the instruction program. So whenever both LEDs are on nothing but microprocessor just now load the instruction. Okay. I want to tell about a microprocessor execute move A, comma B. What first step now? Fetch. Fetch nothing but both are on only. Whenever both are on nothing but we are understand like okay, microprocessor just now load the instruction only. The meaning. Understood now? Okay, no, just normal write operation 0, 1. Read operation 1, 0. No LEDs are blinking, dangerous situation. Okay, something blink compulsory, nothing is blinking, nothing but what happened? Halt. So microprocessor status now, the microprocessor status indicate the which lines? S1 and S0. The two lines are status lines only. They are control lines only. ALU is a special control line only. So how ALU works nothing but also contain the tri-state buffer storage there. Okay, ALU also. Now how AD0 to what? Tell me AD what? 7. How tri-state buffer works nothing but your AD. You can see your tri-state buffer is there now. Yeah. Tell me A7. So this is a called a data lines only. Data. The data. D0 to D7. Okay. So AD0 to AD7 by default works like a working like a, tell me which bus, tell me. Which one?
Data bus.
By default only. Default always data one now. Okay, default is a data. But whenever you want to, those lines convert to the address only. So every line can to what, tell me? Tri-state buffer. Tri-state buffer, that one more state is there, no? This state is enable. The content what, tell me? ALU. Enable. The enable, then tell me output equal to what? Input. Output what? Input. This the output coming to here, A0. The output coming to here, tell me A7. Like 8 buffers are there only, 8. Just AD0 to AD7, 8 buffers are there only. This whole thing we can call the latch. Okay, no, the latch now. So address latch enable. Okay, no, this entire latch enable now. So then outcome is what, tell me? What outcome? Address. Whenever ALU enable. Default what, tell me? Data. Default what? Data. D0 to D7. So the next session we are discussing about microprocessor functional block diagram. I'm going to explain the next instruction directly. Okay, no, the next. Okay. So the function block diagram, a very important session first. Okay. How the assembly instruction works. Tomorrow I'll show demonstration. Okay. So I'll explain first move A comma B, exactly how it works now. I will explain the bus communication diagram. I will explain the clock diagram. Everywhere I will explain the one instruction clearly. After that one, we can start all the instruction tomorrow. Tomorrow we are going to start the data transfer, arithmetical, all the assembly instruction one by one study. Tomorrow we study like ABC like that. Okay, now the language no first. All the instruction we study tomorrow. So next day after tomorrow we write the program on it. Okay, ALP programming start writing on. Tomorrow we start write the ALP only, but small basic level 4 or 5 lines program we writing on. Simple ALP. Tomorrow we start writing on it.